Today we're going to be covering bearings, and our objective is to be able to draw a picture given bearings, and then we will eventually use law of sines and law of cosines to solve for any missing angles or side lengths. So how do you graph a bearing? Our initial side of your angle goes on the x-axis, or on the axis of the first cardinal direction. So if it says north, you're going to have your initial side on the north. Okay, if it says south, it's going to be on the south end, or east or west. The terminal side rotates the indicated degrees towards the second cardinal direction. So the first cardinal direction is where you start, the second cardinal direction is where you end. So here are 4 examples. Our starting cardinal direction is north, our ending is west. Here's south, then east, northeast, and then southwest. And the degree tells us how much to move from the first cardinal direction towards the second. So to draw each of these, if I start at north, if this is my north, south, east, and west, my initial side is going to be going towards the north. I'm going to rotate 30 degrees towards the west, and that would be my angle. 30 degrees would be right there. Now if I have south as my first cardinal direction, that would be south, I'm going to now rotate 75 degrees towards the east. And this is where south, 75 east would be. And again, if I have north as my cardinal direction, we usually have north and south as our beginning ones always, and then east and west is how we move from there. I'm now going to rotate 83 degrees towards the east. And then my last one would be south. I'm going to rotate 17 degrees towards the west. And that's really the main part of today. If you can understand that concept, you should be able to do all the problems. The biggest thing you want to do is draw your picture big enough so you can see this detail in your graph. In our first problem, our main goal is to just draw the picture. We've already spent days kind of using law of sines and cosines to solve a triangle once it's drawn, but now we're going to actually just concentrate on not the solving part, but the drawing part. So the first example says the Federal Communications Commission is attempting to locate an illegal radio station. It sets up 2 monitoring stations, A and B, with station B 40 miles east of station A. So what would that look like? We know station B is east of station A, so station A might be here, and it says east, would be this direction, is station B. And I know those are 40 miles apart, so I'm going to write 40 miles. All right, station A measures the illegal signal from the radio station as coming from a direction of north, 48 degrees east. So what I'm going to do at A is put my little north, south, east, west. That's what you want to do on this. Each vertice should have kind of your little north, south, east, west crosshairs. So now from here, I want to go north and rotate 48 degrees to the east and start to draw my angle. So this is my 48 degrees. Okay, and it's going to get to some illegal station. Okay, so here's the illegal station. Okay, and I'm just going to call it C for now because it's a crime. We'll do that. So C for a crime. Station B measures the signal as coming from a point north, 34 degrees west. So again, from B, so I'm going to do my little crosshairs. My angle comes from the north, but I have to rotate 34 degrees to the west. And I know these should hit. Again, we're not drawing it. It's hard to draw it accurately here, but we know they're going to meet, but this is going to be my 34 degrees. And again, if you notice, these are on the outside of my triangle, which is okay. How far from the illegal radio station how far is the illegal radio station from monitoring stations A and B? So what I'm looking for is little b and little a, if I was going to actually go through and solve. But how do we actually use this information to help us get to the parts of a triangle? Because remember, our goal is to have this triangle, ABC, and the only thing so far I know is side length AB. I don't know any angles inside my triangle. So how do we use the bearings to help us get to the part that we already know how to do? Well, the nice thing about these little crosshairs is these form right angles. Okay, our north, south, east, and west are perpendicular to each other. So I know that this little crosshair here should add up to 90 degrees. Well, if this is 34, I know this is 56 degrees, which lets me know this angle is 56. Same thing here. If this is 90, I know this should be 42 degrees. So I put 42 right here. So I like to draw kind of this picture bigger if I can, because you want to be able to see all the detail. And then off to the side, I just draw my triangle without all the extra bearings part just the information I need. And now this is what we've done in 13.5 and 13.6, our law of sines and law of cosines. So in number 2, it says two airplanes leave an airport at the same time on different runways. One flies on a bearing of north 66 degrees west at 325 miles per hour. The other airplane flies on a bearing of south 26 degrees west at 300 miles per hour. How far apart will the airplanes be after 2 hours? So there's a lot of information here that we have to take into account. One, we have this airport. Okay, so I'm just going to, and I kind of like to read through to know which direction I'm going. I have an airport and I'm going northwest and northwest and southwest. So I want to make sure I have room going to the left. So I'm going to put my airport, say, over here. I'm going to do A for airport. Okay. And if you want to actually write a word out to help you with word problems, go right ahead. So there's my airport. 1, so I'm going to put my little bearings. One airplane flies on a bearing of north 66 degrees to the west. Okay, so that's plane 1. Okay, so let's do that, plane 1. Okay, the other airplane, this is 66 degrees, flies on a bearing of south 26 degrees. Now 26 is less than halfway, so if you notice, you want to do your angles, they're not going to be super accurate, but if it's more than halfway or less than halfway, you want to at least do that. Okay, so I'm going to fly this angle. Okay, I'm going to fly down, and this is plane 2. Okay, plane 2. So now I know this is 26 degrees. I want to know how far apart they're going to be, so that would be this distance right here is what I'm looking for. Now that I have this, I'm going to draw my triangle kind of off to the side to make it a little bit easier, only the parts I care about. So here's my A. I'm going to say maybe plane 1 is B, and plane 2 we'll say is C. Okay. I actually know this is X, but I don't know anything inside the triangle. But what I haven't taken into account is this, how fast they're flying. Plane 1 is flying 325 miles per hour, but I want to know how far apart they're going to be in 2 hours. So if you fly 325 in 1 hour, you fly double that, or you're 325 times 2, which is going to be 650 miles. Okay, so I double that. My other plane was flying 300 miles per hour, but again, if you go for 2 hours, now it's 600 miles away. So now I have 2 side lengths, but I don't have any angles, and I know I need at least 3 pieces of information to use law of sines and cosines. So if I look inside, here's where my angles are. Remember, I know this top part is 90 and the bottom part is 90, so this whole thing should add up to 180. So that tells me that I know if one angle is 66, the other angle is 26, 2, 1, right? So we get 92 degrees is what these two add up to. But I know the whole thing should add up to 180. So this is going to tell me that the inside angle is 88 degrees, which means I have 88 here. Now I can use law of cosines. So my last example says 2 ships leave a harbor at the same time. Ship A travels on a bearing of south 12 degrees west at 14 miles per hour. Ship B travels on a bearing of north 75 degrees east at 10 miles per hour. What is the bearing from ship A to ship B after 2 hours? Now this is different because I'm asking what is the bearing. These are always a little bit more difficult because you're now solving for an angle, and our angle problems seem to be a little bit harder for us. So again, 2 ships leave a harbor at the same time, and our harbor, I'm going to put over here because I'm actually sailing northeast and southwest. So one is going northeast, one is going southwest. So maybe I'll put it right about here. Okay, so this is my harbor. I'm going to call it H. So let's just put an H next to it for now. Okay, so I know one ship is sailing at, ship A is at south 12 degrees to the west. So that's not very much. So 12 degrees to the west. Okay. At 14 miles per hour. Okay. And again, we can kind of do this right away. If it's 14 miles per hour for 2 hours, that's 28 miles. My other ship, actually move that on the outside. My other ship is going north, but 75 degrees, which is more than halfway, at 10 miles an hour, so this is going 20 miles. Okay. So if we kind of look at what we have here, kind of move the H on the outside now, I want to know I draw my triangle. So this is ship A and this is ship B. And this is my 12 degrees and this was 75 degrees. So again, if I draw my triangle kind of off to the side, okay, here's my harbor, here's A, here's B. I know this is 20 miles. I know this is 28 miles. But I don't know any angles on the inside. But what I do know is this little part is 12. I know this part right here, because it's a right angle, is 90. And this total on the top was 90. Well, if this is 75, this is 15. So if I take my 15 degree angle plus the 12 degree angle plus the 90 degree angle, I can get what I have total. So that's going to be, what, 117 degrees. So now that I know that's 117 degrees, I can write this in. But I don't want to know a side length. I want to know the bearing, and this is where it's important, from ship A to ship B. So I'm starting at ship A, so I'm going to put my little bearings at ship A. If I want to know from ship A to ship B, I need to figure out which direction I'm going. We always start with the north or south first. So if I look at A, and you're telling someone directions, how do you get from A to B? They're going to go north, east. They're going to have to go up and to the right. So it's northeast. I need to figure out what the degree is. And the degree always goes from our north, and it has to rotate all the way to the path that ship A should travel. And I know this isn't the straightest line, but ship A is going to start here and follow this blue line. Well, remember, if I start at north, I have to start straight up, and I go over to that line. So this is the angle I need to find. Okay, so how am I going to do that? Well, let's go back to my original picture and think, I know I can find this angle because it's an angle inside the triangle. I can do some law of sines and cosines or a combination and find the angle inside. But that doesn't help me find this little piece on the outside, which I have to add to it. So I know it's going to be this part on the outside plus whatever my theta is. So how do I find that part on the outside? Well, we have to go back to a little bit of geometry. So I have my crosshairs at A and my crosshairs at H. And if I just draw the line between them, I know that this little part here was 12 degrees. And if you remember from geometry, this south and this north are parallel, and I have this transversal. This and this, those are called alternate interior angles, which are congruent. So this is 12 degrees. So I know this is 12 degrees because of these little crosshairs. You're going to get a lot of parallel lines when you draw these in, which means a lot of alternate interior angles. So I know if I can find this angle inside, I'm going to add it to 12 degrees, and that's going to be my bearing from ship A to ship B. I hope you feel a little bit better about being able to draw a picture given some bearings. We're going to be practicing these in class and then using law of sines and law of cosines to ultimately solve them.